We're on page 15.
It's Miss Smith now.
That's right. That's right. Miss Smith.
Yeah.
So let's talk about this 6 points. You guys, there's 6 points, and there's the 5-6 rule. If you get 5 of these 6 slopes right, you're right. You get the full point. 2 points. Here's the slope. Let's go find the slope at this point when 0, 0. What would be the slope at 0, 0? 0 over anything, I got you, is 0. Anything with a slope of 0 is just horizontal. What about 2, 0? Has another slope of 0. Okay, you guys, the point 0, 1. What's that looking like? 0, 1. Nice. -1, a slope of -1 is just going to be a little 45-degree angle. 0, 2. -4. So it's just going to be a lot steeper, right? 2, 1. 2, 1. Nice. I agree. Look at that. That was quick. How about 2, 2? +4. Hi. But the first point is always going to come from writing the equation of the tangent line when x is 2. Well, look at that. They gave us a point. Did they give us a slope?
I'm out on calculus.
Who can help me with the equation of that tangent line? Y minus 3. What's my slope at the point 2, 3? That wasn't here in my chart, and that's okay. What would be the slope at 2, 3? 2, 3. Oh, yeah. And you remember that? Yeah. Okay. Well, I know. I do. I remember grading that. X minus 2. So then how do you find an approximation when they want f of 2.1? We just got to say, oh, 9 times what? Yeah, you're just putting that 2.1 in for x. Minus 2 and throw that 3 on the other side and you're done. This is another 2 points. So you guys, if you just get those 4 points, a point would have been here and a point would have been here for these signs, negatives and positives. Here's a third point, and then here's a fourth point. You've got 4 out of 9. Remember, Blake, we're looking for 3 or 4 points every time. We haven't even had to look at these crazy differential equation part yet, but that'll be 5 points on this one. Let's go practice that. Okay, dy dx equals y squared times over x minus 1. You guys, the first point always comes from separating the variables. Separating the variables. Whew. I'm going to rewrite this top just to see if that helps you. This is the same as 1 over x minus 1 times a y squared. That's the same as that. Well, how would we rewrite this to separate those variables? How would I separate that? How would I get my y squared on the other side? Divide it. So I'd have 1 over a y squared dy. What do I have left on the right side then? 1 over, very good. 1 over x minus 1 dx. Okay, peeps. You just got 1 point. So now we're at 5 out of 9. What's the next step? Push, push. Antiderivative of this side we might struggle with if we don't think about it as this. It's 1 over y squared, which is the same as y to the -2nd. Get rid of that exponent. What would that exponent become? Y to the blank over blank. Yes, y to the -1 over -1. Could I just say negative y to the negative first instead of saying over -1? Yeah. Antiderivative 1 over x minus 1. Anytime that variable is to the first power in the denominator, it's always natural log. ln of x minus 1. What am I missing? Nice. How could I just rewrite this guy to make my life a little easier? Because I'm about to plug in a point to it. This scares me. -1 over a y to the first, right? Just rewriting it, I think, really helps us plug in a number to it. Okay. Let's go plug in my x and my y. What am I going to have over here when I plug in this point? -1/3. Good. -1/3 is my natural log of, 2 minus 1 is just 1. What's the natural log of 1? Very good. That thing's gone. Did I do that on purpose? You know it. We got negative 1/3 is my C value. At this point, we go like this. Boop, and we plug it back in. Let me talk about how many points we got. 1 for separating the variables, 1 for doing this, 1 for getting my C. So we've got 3. We got to go plug C back in and get Y by itself to get my 4th and 5th points. Here we go. Here we go. Negative 1 over Y equals natural log of X minus 1. My C is negative 1/3. We got to get Y by itself. And right now, Y is in the denom. How could we get it out of there? Multiply by it. Psh, psh. If I multiply by it, I'd have a negative 1 equals. I always just leave it on the right side and I don't distribute it through. I just say, okay, it would be Y times that whole right side. And what's my last thing? Get Y by itself. What would we do? Y equals, divide by negative 1 over ln x minus 1 minus 1/3. So on page 17, it says the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight, yada, yada, yada. They gave us B of t is the weight of the bird, and dB dt, so the rate that the bird is gaining or losing weight, is here. And this is something to note. At time t equals 0, when the bird is first weighed, it weighs 20 grams. Just a little itty bitty birdie. Let B of t be the solution with the initial position. And is the baby bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? This isn't really a Unit 7 topic, but since we're getting close to the AP test, let's practice it. Any ideas what we might want to do to figure out if it's gaining weight faster when it weighs 40 grams or when it weighs 70 grams? How would we figure that out? Yeah, we could just plug it in. Plug what in? Yeah, the 40, because B is talking about, B is the weight. T is the number of days. B is the weight. So could we go find my rate at B is 40 grams versus my rate at B is 70 grams? You guys, let's go simplify this. What's 100 minus 40? 60. What's 60 divided by 5? 60 divided by 5 is going to get me 12. Not that we have to simplify it, you guys, at all, but it might help you get an answer. 100 minus 70? 30 divided by 5. So, what does it say? Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? The rate that it's gaining weight when at 40 grams is bigger than the rate that it's gaining weight at 70 grams, right? So that's exactly what we'd say when they say explain your reasoning. Now, when you say the rate that it weighs when it is 40 grams, you could always just say that as dB dt. When B was 40, that's a way to say that. The rate that it was gaining weight when it was 40 grams is greater than the rate that it was gaining weight when it weighed 70 grams. That could just be a shorthand if you don't want to write all those words. Therefore, bird is gaining weight faster when weighs 40 grams. I guess another way to do this that I bet that they'd give you points for, our work here was very thorough. So if you just wrote 12 is greater than 6 right here, and then this statement, they'd be good with that. 12 is bigger than 6, because you already wrote really this part over here. So if you just said 12 is bigger than 6, therefore the bird is gaining weight faster when it weighs 40 grams, we're good. Okay, here's where the big points come from, people. Here's where the big points come from. When they say separate those variables, they're ready to give us 5 or 6 points. This one, they're going to give us 6 points, and I'm going to tell you why. There's a zinger on this one. There's a zinger. Let's start out with my dB dt. Let's bring that down. So we know dB dt is 1/5 100 minus b. Okay, question. Separate those variables. Let's see if anyone could get just the first point of separating those variables. Any idea? How am I getting my b's over there? My b. Yeah, we're going to divide it. So what would I have on that left side? Well said, math. 1 over 100 minus b dB. What's left? 1/5 dt. We got it. We got it. We got it. We got it. We got a point. We love a point. We love points, guys. Here's where they're going to give you 2 points because the antiderivative on the left is bad. It's worse than the antiderivative on the right. Let's start with the right. We love it at 1/5. Whose derivative is 1/5 with respect to t? Yeah, 1/5 t, and I'm going to throw a plus c on it. If you get the right side, they're going to give you a point. They're ready for you to mess up the left side because we've actually only seen this happen one other time. This is a Wednesday. I haven't seen you guys in a decade. Whew. The antiderivative, let me put it this way. If it was 100 plus b or 1 over b plus 100 would be, anyone? We know this one. We just had one like this on the last one. ln of 100 plus b. And here's why. Here's why. What's the derivative of this to check it? The derivative of natural log is always 1 over that 1 over that quantity times the derivative of that quantity. What's the derivative of 100? 0. And the derivative of b? Just 1. Why is this one a little different? It's the negative b. So does this have a little chain rule involved? Okay. When we have some chain rule going on, we would have to u sub. And guys, I'm going to vomit if we've got a u sub. You're going to vomit because u sub's a lot of work. We've done one practice of this, can you think what the u sub would get us an extra of that we would just have to do the opposite? Meaning, you're saying this has a little, what if we took the derivative of negative b, what does that get us? An extra, it gets us a negative, right? The derivative of negative b is -1. Could I compensate for that and take care of it? So here's how I want you to think of this if we could do it without u sub. You're like, okay, I know that the antiderivative is just going to be ln of 100 minus b. But when I take this derivative, what would I get? When I take this derivative, wouldn't I get 1 over 100 minus b times a -1? Because the derivative negative b is -1. Do I need that? What could I do to this to get rid of that? Yeah, if I just do the opposite and multiplying or dividing by a -1, same diff. You could put it over -1. But if we're saying, ooh, this would cause me to multiply by a -1, I've got to divide by a -1, which is the same as multiplying by a -1. This is going to compensate for that. That's hard. Am I going to put that on your Unit 7 test? No. Am I going to put it on your group test? Yeah, because I need someone to remember it. Are they going to put it on your AP test? I'd say that there's a 80% chance that they're not going to. But I just want us to see it, okay? So on your individual test, I'm not going to make you do it. When your group does, maybe I will. Okay, so we're here. That's a tough part, though. That's a tough thing. Let's now plug in our point. Let's go get what my constant is. And negative ln of, what do we got? Negative ln of 100 minus 0 or 20? 20, very good. 100 minus 20, so you could just write ln of 80 if you want, or you could write 100 minus 20, I don't care. Equals 1/5, what's my t? 0, so maybe you don't even want to say that, and we would just say negative ln of 80 is my c. And I'm going to go plug that right back in here. Good question. Okay, you guys, we got negative ln 100 minus b. Oop. Come on, little pen. 100 minus b equals 150 minus ln of 80. Guys, before we can this, you go get rid of this thing. How am I going to get rid of this thing? Yeah, let's just divide out that -1. So then I'd have ln of 100 minus b equals negative 1/5 t plus ln of 80. Are we ready to eat it? Boop, boop. Now, to your point, Mags, here, when I get rid of these bars, I must plus or minus over here. Yep. So I've got e to the negative 1/5 t plus ln of 80. Now, Kendall, this kind of goes back to that question that we were asking yesterday. Of when is it going to be a plus e and when is it going to be a minus e, right? We need to make sure when we plug in a 0 for my t, we get a positive 20. We really don't have to worry about it yet till we get my b by itself. I really didn't give you guys enough space for this. I apologize about that. To get b by itself, do you want to subtract 100 or add a b? Subtract 100, okay? So you're saying we'd have negative b is negative 100. And at this point, I might still have that plus or minus because I haven't thought about it, and that's okay. Plus the ln of 80. And then if I've got to get rid of that negative, I've got, if I divide that by a negative 1, b equals 100. And then we got to think, do we want the plus or the minus? When I plug in a 0 for my t, I need to get 100. Oh, this is a hot mess. When I plug in a 0 for my t, I need to get 20 for my b. Is that right? From that point? I need to get a 0 and 20. People. If I plug in a 0 right here, what's negative 1/5 times 0? 0. So I would have a way to think about this is e to the ln of 80. How can I rewrite that? Isn't that just 80? Can't I just bring that 80 down? So do I want 100 plus 80 or 100 minus 80? I want it minus. So I'd have e to the negative 1/5 t or plus ln of 80. Or another way you can write it is 100 minus 80 e to the 1/5 t. So I just dropped it right here, plugging in that 0 for t to help me see. I would need it to be a minus. Let me say that one more time. Right here. If I plug in a 0 for my t, I would get 0 here, e to the ln of 80, which is just 80. 100 minus 80 will get me 20. And that's what I needed that point to be. So this is my final equation. Whew. Guys, that's a hard one. I'm not going to put one like that on your test. That's really hard. But I think it's good for us to see it. Page 18. All right, mountain lions. Mountain lions are growing over time. Population, woo! At time t equals 0, the population is 20 mountain lions. That's funny. This is the same point as last time, 0, 20. Okay, we got this rate that these mountain lions are growing. Let's go see how many points we can get. They said separate those variables. Let's do it. What's that first separation going to look like? I love your 1/4 dt. How did you get rid of that the 220 minus p? Exactly. He's like, oh, I got to divide that. 1 over 220 minus p dp. What's ornery about this one? When that variable is negative, we got to anticipate that with my antiderivative. We got this, people. Whose derivative is 1 over 220 minus p? It is going to be an ln. How are we going to handle that minus p's derivative of a negative 1? Boop, throw that negative out front. And why would I do that? Because when I take the derivative of this now, this negative, the derivative of this now, let me just show you again. You don't have to write this. But if I took the derivative of this, I'd get negative 1 over 220 minus p times the derivative of negative p is negative 1. And that's what I started with. If I don't put this negative here, I would have had this. And that is not what I started with. Jay, bro. So it was like all right, people. So you just did the hardest part. Antiderivative of the right side. 1/4 dt. Yeah, 1/4. What am I missing? T plus c. Well said, row. Whew, they will always give you 2 points for this step if they're making you undo a chain rule here. So you can still get 1 point by taking that right side. Whew. Okay, peeps, let's plug in a point. Negative ln of, what are we going to say? 220 minus how much? 20 is going to get me how much? ln of 200 equals 1/4 times 0. Do you really want to say it? Nah. So I got my constant. We're going to go plug it in. Negative ln of 220 minus p is 1/4 t minus an ln of 200. Before we can e it, what do we got to do? Yeah, get rid of those negatives, you guys. Line taxes. Woo! Okay, I got her in my head now. You guys got a break right after this. Let's just get through this guy. Negative 1/4 t plus an ln of 200. Now am I ready to e? Sure am. When I get rid of those bars, we're going to throw a plus or minus with my e. How many people are at this point where you're like, I hate writing this 200 here, this e to the ln of 200. Some people might be bringing this down now, and I'm down with that as a little coefficient. I'm fine either way, but you don't have to. You don't have to at all, but you could. So
if you bring it down, does it have to be like plus or minus 200?
exactly, it'll go in front of the e between the plus or minus. So let's do it. So I'm going to go what Roro said last time. He wanted to subtract the 220. So I got a negative 220 plus or minus 200 e to the negative 1/4 t. So that's how we'd write that, Margie. When I divide out my negative 1, p equals a 220. We got to think, if we want to plug in a 0 for my t, I need a positive 20. Which of these would I choose if I'm plugging in a 0 for my t? Anything to the 0 is 1. So e to the 0 is going to get me 1. I'd have a 200 there. So which one do I want? Minus 220 minus 200 is going to get me a positive 20. Bless you.